A pleasant day to everyone. Today, we're going to discuss the Coulomb's law. But before anything else, what you must keep in mind that we're going to have here are the following. First, the definition of the Coulomb's law, followed by the sample problems that we have under the Coulomb's law. Let us define first what is a Coulomb's law. This law was stated by Charles Augustin de Coulomb, and according to him that the force of attraction or repulsion between two small charged bodies is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So tatlong bagay ang tatandaan natin under the Coulomb's law. Una, yung force. So when we are talking about force, it can be attraction or repulsion. So tuwing kailan ba nagkakaroon ng attraction and repulsion? When we are talking about the Coulomb's law, kailangan din nating tingnan dito yung dalawang charges natin. So the charges can be both positive or it's either both negative or pwede naman in opposite sign or symbol. So if they are both positive or both negative, always remember the force of attraction between them will be repulsion. So hindi sila magtatagpo. Well, kapag yan ay positive and negative, magkakaroon ng attraction. Yan. And based in our definition a while ago in the previous slide, so we have here the force of attraction and repulsion can be solved using this formula. So F is equal to K, Q1 and Q2 over R2. So himay-himayin natin. Yung F natin dito is our force of attraction and repulsion. So remember, kapag yan ay attraction, dapat meron silang opposite charge. Pero if that is repulsion, dapat yung isa ay positive at yung isa naman ay negative charge. Then, since we have here the Q, we have Q1 and Q2, and the unit of measurement that we're going to use for it is coulomb. And lastly, we have the R. R is the distance between the two charges or the two charged bodies, which is in meters. So, anong gagawin kapag hindi siya naka-meters? So, kailangan natin siya i-convert so that we can cancel out yung mga unit na pwede natin i-cancel upon solving it. And lastly, we have the constant of proportionality value, which is 9 times 10 raised to 9 Newton meter squared per coulomb squared. Let's try to apply our formula into a sample problem. So before that, let's read first the problem. So what is the magnitude and the direction of the force on a charge of 4 times 10 raised to negative 9 coulomb? That is 5 centimeters away from the charge of positive 5 times 10 raised to negative 8 coulomb. Now, based dito sa given natin, kung i-identify natin siya, meron tayong Q1 and Q2. So, your Q1 for this problem will be positive 4 times 10 raised to negative 9 coulomb, while your Q2, that will be positive 5 times 10 raised to negative 8 coulomb. And our R, na naka-centimeters, which is 5 cm, kailangan natin siya i-convert into meter. So, ilan bang equivalent nito sa meters, yung 5 centimeters? We all know that in every 1 meter, meron tayong 100 centimeters. So, let's try to convert. So, we have 5 cm, open and close parenthesis. So, we have 1 meter sa taas and yung 100 centimeters sa baba. Then, cancel out the unit centimeters. Then, all you have to do, multiply 5 times 1. We have 5 meters over 100. And simplifying it, we will have 0.05 meters. Yan. Since we already have our R, therefore, we can now solve for the unknown. But before that, sulat muna natin yung K constant value natin dito, which is 9 times 10 raised to 9 Newton meter squared per coulomb squared. So since we are looking for the two things here, we have the force and the direction of the charge. So let's try to solve first for the magnitude of our force. So for that magnitude, all we have to do is to use the formula F is equal to K Q1 Q2 over R squared. Let's substitute. We have 9 times 10 raised to 9 Newton meter squared per coulomb squared multiplied by 4 times 10 raised to negative 9 coulomb times 5 times 10 raised to negative 8 coulomb divided by 0.05 meters raised to 2 or squared. If we're going to simplify this, you will get 0.00072 newtons. Or, in scientific notation, your answer will be 7.20 times 10 raised to negative 4 newtons. That will be our F. Now, since our charges are both positive, definitely we can say that the force of our charges here will be repulsion. Let's have another example. So, two identical charges repel each other with a force of 1.0 times 10 raised to negative 5 Newton when they are 20 centimeters apart. So, letter A, what is the force on each when they are 5 centimeters apart? So, una, kailangan natin munang i-identify kung ano yung pinapahanap. For this problem, we're going to solve for the what is the value of these two identical charges. But before that, since given na naman ng force natin, napin muna natin siya at 20 centimeters apart. So our given, so that muna natin, we have force which is 1.0 times 10 raised to negative 5 newtons. And also we have our R, which is 20 centimeters. If we're going to convert this into meters, so we have using the conversion factor, 20 cm, open close parenthesis, for every 1 meter, we have 100 centimeters. So, cancelled ang unit ng centimeters. So, therefore, we have 0.2 meter. Then, with this, we also have our K, which is 9 times 10 raised to positive 9 Newton meter squared per coulomb squared. So since we are looking for the identical charges, therefore we can say that our formula, which is can be derived from the mother formula that we have. So using the formula F is equal to K Q1 Q2 over R squared. Since we have identical Q1 and Q2 value, so we can say that FR squared is equal to K Q squared. So let's have Q squared dito para at least mas madali natin siyang ma-solve kasi identical naman yung value natin. The next step is divide both side by K para ma-cancel out siya dito. So our Q is equal to FR squared over K. Since merong square yan dito, we need to extract square root on both sides. So your Q formula now will be square root of FR squared over K. Then substitute natin yung given natin. We have here 1.0 times 10 raised to negative 5. Negative 5 newtons multiplied by our R, which is 0.20 meters squared divided by the constant of proportionality, which is 9 times 10 raised to 9 Newton meters squared per coulomb squared. So extract square root. So for our final answer, the answer will be 6.67 times 10 raised to negative 9 coulomb. So that is our Q answer. But since they are identical, we can say that this value for Q1 and Q2 can be both positive or either both negative. So that will be our Q1 and Q2. So since meron tayong Q1 and Q2, we can now solve for our force at 5 centimeters. So same formula. So F is equal to K Q1 Q2 divided by R squared. So since this is identical, we can say that 6.67 times 10 raised to negative 9 squared times natin dun sa constant proportionality. Hindi siya cash. Let us try to read this problem number 2. So, two identical charges repel each other with a force of 1.0 times 10 raised to negative 5 Newton when they are 20 centimeters apart. So, therefore, if we're going to try to put this glass into a diagram, we have Q1, which is 20 centimeters apart from Q2, so 20 cm. But we do not know the value of Q1 and Q2. So therefore, since they are identical, we can say, and they are repulsion happening, so we can say that the value that we can obtain can be both positive or can be both negative. So it depends. So therefore, let's try to analyze and write first the given on our problem. So we have here our force, which is 1.0 times 10 raised to negative 5 newtons. We also have our R, which is 20 centimeters. So, kailangan natin siya i-convert into meters ulit. So, therefore, we have 20 cm. Alam naman natin, in every 1 meter, meron tayong 100 cm. So, using the conversion factor, 100 cm sa baba, 1 meter sa taas. So, cancel out yung centimeters. So, therefore, we have 0.2 meters. And our K, which is 9 times 10 raised to 9 Newton meter squared per coulomb squared. Now, for this problem, since our Q1 and Q2 are identical, we can say that the formula will be look like this. So, F is equal to K. Instead na Q1 and Q2, you write Q squared since they are identical in value over R squared. The next step is we need to get the formula for Q. So, cross-multiply muna natin. We have KQ squared is equal to FR squared. But since we're looking for Q, divide both sides by K. So, to that we can cancel it here. So, we have Q squared is equal to FR squared over K. But since we are looking only for Q, all we have to do, extract both sides yung square root. So your Q formula now will be Q is equal to the square root of FR squared over K. Substituting the value, we have the square root of 1.0 times 10 raised to negative 5 newtons multiplied by the square of 0.2 meters divided by 9 times 10 raised to 9 Newton meter squared per coulomb squared. Since charge ang hinahanap, definitely our answer must be in coulomb. So Q, when we simplify this one, we will get 6.67 times 10 raised to negative 9 coulomb. So this is the value of our Q. So, since sabi nga natin kanina, identical yung value and we are talking about two charge, so these two charge can be it's either positive pareho or parehong negative. So, we can say that Q1, Q2 can have two values here. It can be both positive, which is positive 6.67 times 10 raised to negative 9 coulomb, positive 6.67 times 10 raised to negative 9 coulomb, or negative 6.67, and also 6.67 negative times 10 raised to negative 9 coulomb. Yan. Okay, so this problem, number 2, is actually our same problem in our previous slide. But here, we need to look for the value of the force at 5 centimeters apart. So we already solved the Q1 and Q2. They are identical, so Q1, Q2. So let's try to use positive. So positive 6.67 times 10 raised to negative 9 coulomb, and another positive 6.67 times 10 raised to negative 9 coulomb. Or it's up to you. You can also use both negative because since they are repelling from one another. And here, our R now will be 5 centimeters. So same process. We need to convert 5 cm into meters. So using the formula 5 cm, open close parenthesis, as we all know, in every 1 meter, meron tayong 100 cm. So cancel out. So the same. So 5 times 1 divided by 100. So 5 meters over 100. So we will get 0.05 meters. So since we already have the value of the R here, we can now solve for the force between these two charges, identical charges that we have. So F is equal to K Q1, Q2 over R squared. And don't forget our K constant value, which is 9 times 10 raised to 9 Newton meter squared per coulomb squared. So substitute, we have 9 times 10 raised to 9 Newton meter squared per coulomb squared. Since we have identical value for Q1 and Q2, we can say that it can be 6.67 times 10 raised to negative 9 coulomb raised to 2, since pareho naman siya ng value, over R, which is 0.05 meters squared. So if we're going to simplify this, 9 times 10 raised to 9 times 10 raised to 9 Newton meters squared divided by 0.05 meters squared. So the answer here will be, our force will be 1.60 times 10 raised to negative 4 newtons. Let's have the nature and characteristics of electric field. So define first what is electric field. So ito yung region na kung saan it is surrounded by a charges. So as we can see on these two example, we have here a positive charge here, wherein since alam naman natin ang mga positive charge ions, they tend to give electrons, diba? So therefore, with this kind of scenario from letter A, you can see there that the electric field is going outside and finding out where is the negative charge is. Well, for letter B, so as you can see, the positive terminal here are trying to reach out the negative terminal because that is the way or the process of moving of electrons. So from the positive terminal going to the negative terminal. The main essence of having this picture is for us to show that positive charge ions are trying to reach the negatively charged, and therefore the spectra of lines here of electrons are known to be the electric field. So since they are in opposite charge, so what will happen? They will attract one another. And since here, in our next example, we have both positive, you can see that the electric field that we have are trying to repel with one another. So there is this what we call repulsion that is happening on this scenario. To sum up everything about electric field, when we are going to have the definition of it, this is actually the region around any charge and it experiences electric charge. And here, in the definition, we have the ratio between electric force and charge for us to solve for the value of electric field. So therefore, if we're going to put this into a formula, E, which stands for the electric field, is equal to your force over your charge. And we all know that force is a unit of Newton, and for that charge, we have Coulomb. So the unit of measurement for electric field is Newton per Coulomb. And another things that you must remember is the electric flux. So pag sinabi naman natin electric flux, this is the number of electric field lines passing through a surface. So it came from the Latin word fluxus, meaning to say it is flowing. So the flow of electrons plus in a certain area describes how an electric flux happens. And for this class, when we are talking about electric flux, for you to solve for it, you just multiply the product of electric field with the area. So therefore, we're going to write, we have here like this. So electric flux is equal to your electric field times the area. But if we're going to have an angle involvement, so we can use the formula E, A cosine theta. Or pwede rin naman, if given ang force and charge and the area, you can solve for the electric flux using your force times the area over your charge. Kung may angle naman, FA cosine theta over charge. So these are the other formulas that we can use to solve for the electric flux. Now let's try to answer the problem related to electric field and electric flux. So here I have a flat surface of a rectangular object which has a dimension of 5.25 meters by 2.5 meters. Is rotated through a uniform horizontal electric field of 11.5 newtons per coulomb. So what is the electric flux if the surface, letter A, if the electric field is at 30 degrees and letter B, at 70 degrees. But una, let's try to solve for our electric flux at a surface. So let's write first the given. Our given, we have the area of a rectangle which is 5.25 meters times 2.5 meters. We have here 13.13 meters squared. And also we have the electric field which is 11.5 newtons per coulomb. So let's try to find the electric flux at a surface itself, yung wala pang angle. So using the formula EA. So substitute, we have electric flux is equal to your 13.13 meters squared multiplied by the electric flux which is 11.5 newtons per coulomb. Same lang yan kahit magbaliktad. So the answer will be 151.00 Newton meters squared per coulomb. Next, so what will be our electric flux at 30 degrees rather? So electric flux is equal to EA cosine theta. Substitute natin, we have 11.5 newtons per coulomb times 13.13 meters squared times cosine 30 degrees. So your answer here will be the answer will be 130.77 Newton meters squared per coulomb. And at 70 degrees naman, so we can use EA cosine 70. So substitute natin 11.5 Newton per coulomb times 13.13 meters squared times cosine 70. So we have here 51.64 Newton meters squared per column. Yan. You notice class na habang nagkakaroon tayo ng angle at tumataas yung values ng angles natin, the amount of the electric flux that is flowing is also affected. So as you can see, as we increase the angle, the value of the electric flux also decreases. So it is inversely proportional to this angle. So take note of that. Let's try to solve this sample number 2. For the sample number 2, we are trying to look for the area of an object. So with this value or with this unknown, we have the following given. So we have here the electric flux, which is 14.5 times 10 raised to 8 Newton meters squared per column. And also we have our electric field, which is 14.5 times 10 raised to 5 newtons per column. So using the formula, we have here electric flux is equal to EA. So since we are looking for the A or the area, we need to divide both sides by E. Cancel it out. So A is equal to electric flux over E. So substitute A is equal to 14.5 times 10 raised to 8 Newton meters squared per column divided by 14.5 times 10 raised to 5 Newton per column. So cancel yung newtons and column dito. Yan. So therefore our area is equal to 1,000 meter squared or 1.00 times 10 raised to 3 meters squared. Aside from the Coulomb's law that we have a while ago, we also have another law which is the Gaussian law or the Gauss's law. So this law was stated by Frederick Gauss or Carl Friedrich Gauss, wherein he said that the total electric flux through a surface is actually the total number of charge inside divided by the constant EO. If we're going to interpret what the formula for the Gaussian law, we have here the flux total is equal to the Q total divided by the EO. So your flux total has a unit of Newton meters squared per column, while for your Q total, so since this is the charge, so it is in column, and your EO is actually your permittivity of free space, which is 8.8542 times 10 raised to negative 12 Coulombs squared per Newton meter squared. But we're going to use only 8.85 times 10 raised to negative 12 Coulombs squared per Newton meter squared. Pero hindi all of the time given yung Q total natin. Minsan, ang inakabigay lang ay yung number of electrons. So what will be the case if that will be the scenario? So we can still solve for the flux total using that. So we have here number of electrons or the given electrons in a problem. We just multiply it last with the charge of the electrons, which is your QE, divided by your permittivity of free space. So that's still the formula. If you want to solve for the Q total or the flux total rather, you can use the number of electrons times the QE, which is 1.60 times 10 raised to negative 19 coulomb over the permittivity of free space. Let's apply the Gaussian law formula in this problem. So first, let's read it. The net electric flux through a 3D closed surface is 2.2 times 10 raised to 3 Newton meters squared per coulomb. So how much charge must be inside the surface? So dito, meron tayong binigay na total electric flux. Yan. So we are looking for the charge. So from the given, we have the electric flux, which is 2.2 times 10 raised to 3 Newton meters squared per coulomb, and our EO, which is 8.85 times 10 raised to negative 12 Coulomb squared per Newton meter squared. So since we are looking for the charge, so we can derive the formula from our mother formula, which is electric flux is equal to your Q over EO. Since we're looking for the charge, cross multiply, we have Q is equal to your flux total times EO. Substitute, we have 2.2 times 10 raised to 3 Newton meter squared per Coulomb times 8.85 times 10 raised to negative 12 Coulomb squared per Newton meter squared. So, cancel out yung Coulomb squared and Coulomb dito, and yung both Newton meter squared natin. So, therefore, your Q is equal to 1.95 times 10 raised to negative 8 Coulomb. Let's have another sample problem, but at this point, we have the number of electrons as one of our given. So, let's read the problem first. So, a Gaussian surface is a closed surface in a three-dimensional space through which the electric flux is calculated. Given a sphere Gaussian surface that has a radius of 0.5 meters and encloses 30 electrons. So, una, hanapin muna natin yung formula ng spherical object. So, since this is area, we have the sphere, and the formula is 4 pi r squared because we're going to use this later to solve for letter B. But una, hanapin muna natin yung electric flux natin. With our given, we have our radius, or the R, which is 0.5 meters, and the number of electrons, which is 30. So, let's try to solve for the flux total. So, using the formula, number of electrons times the charge of the electrons divided by the permittivity of free space. So, substitute natin. So, we have 30 electrons times 1.60 times 10 raised to negative 19 Coulomb divided by 8.85 times 10 raised to negative 12 Coulomb squared per Newton meter squared. So, cancel yung Coulomb squared dito. So, magiging Coulomb na lang siya. So, therefore, we have here 5.42 times 10 raised to negative 7 Newton meter squared per Coulomb. So, this is now our electric flux. Then, for letter B, calculate the electric field at a distance equal to 0.5 meters from the center of the surface. So, using the formula for electric field, which is E is equal to your electric flux times or divided by rather by A. So, substitute, we have 5.42 times 10 raised to negative 7 Newton meter squared per Coulomb divided by 4 times 3.14 times 0.5 meter squared. So, simplify. Your answer there will be 1.73 times 10 raised to negative 7 newtons per Coulomb. And for letter C, if we're going to describe the relationship between the number of flux in an enclosed charge, we can say that they are directly proportional. Okay, so I do hope you learned new things about the Coulomb's law and the Gaussian's law. And for your exit pass, this is can be answered using your Genio account. So I have here the following. So for number 1, you need to calculate for the total electric charge or the flux total in a confined surface. So I have here 4 scenarios to answer this. And for number 2, this is an example that we have for the Coulomb's law. So thank you and good luck to your quiz.